Hello students, hope you are all fine. Today we have an example related to optimization in chapter 4, applications of differentiation. The question says, what's the maximum area of a right triangle whose hypotenuse measures 10 centimeters? So it's maximum area, which means it's talking about differentiation, optimization. So area of a right triangle, we need to draw a right triangle. If we have this triangle, this angle is right, this side opposite to right angle is hypotenuse, and hypotenuse measures 10 centimeters. So this side measures 10 centimeters. The base is x, so let us use x for the base. Base is x, so we use this x for base, and height is y, so we use y for the height of this right triangle. And capital A is area of a triangle. Since we have the maximum area, so area will be the primary equation. So as you know, area of a right triangle or area of a triangle in general is half of base and height. Base is x and height is y, and this is the primary equation. And this equation involves two variables, which means we need secondary equation. We can get the secondary equation from the extra information given in the equation. Do we have extra information? Yes. We have a right triangle, we have the measure of the hypotenuse, so we can use Pythagorean theorem. Since I have a right triangle, we can use Pythagorean theorem. Pythagorean theorem is used when I have a right triangle. Pythagorean theorem is hypotenuse squared then equals x squared plus y squared. So x squared plus y squared is equal to 10 squared. So x squared plus y squared is equal to 10 squared. So we can solve this equation for x in terms of y or for y in terms of x. So there is no difference. Let us use x for y in terms of y. We move y squared to this side. It will be x squared is equal to 10 squared is 100. Y squared, positive y squared, negative y squared, since we move to the right side. And square both sides. If we square this side, if we square this side, cancel this and this. X is equal to square root of 100 minus y squared. We are not going to use the negative one because we are talking about lengths, base and height. Base and height cannot be negative. And this is the secondary equation. Now we put equation 2 in equation 1. So we replace x by this amount. So area equals 1 over 2. X is square root of 100 minus y squared. And times y. Now we can organize this one. 1 over 2. We can write y here because it's multiplication. In multiplication, we can change the factors, so it's a commutative property. Y square root of 100 minus y squared. Now it's time to take the derivative of this one. Since I have one variable, look, we have only y present in this equation. So we can use a prime. We use the product rule. Since I have two factors, we can keep 1 over 2 here. if you remember the product rule, first as it is, derivative of second, plus second as it is, derivative of first. So the first factor as it is, we keep the first one, times derivative of second factor, derivative of square root. There is a rule for square root. We can put 2 here. Same one, same square root, 100 minus y squared. And we put the derivative of inside in the numerator. Derivative of 100 is 0. Derivative of negative y squared is negative 2y. And then plus second factor as it is, times derivative of first factor. Derivative of y is 1. Now we can do simplification. We can cancel this 2 with this, and we can multiply this y by this. So it will be a prime is equal to 1 over 2. Y times y, it will be negative y squared over this one, plus this one times this one itself. Now LCD, since I have addition, denominator is 1 here, 1 over 2. This one times 1 itself. This one times 1 itself, plus square root of 100 minus y squared times itself. So it will be just 100 minus y squared. Why? Because if I have radical x times radical x, it will be just x. Here I have radical of 100 minus y squared times radical of 100 minus y squared. So it will be radical of 100 minus y squared all squared, because we have multiplying two similar bases. We can cancel this with this. So it will be just 100 minus y squared. So I have that here. Simplify more. 1 over 2. Negative y squared, negative y squared, negative 2y squared, plus 100 over 100 minus y squared. Now there is no more simplification. We can just make derivative equals to 0. So the whole function will be 0. Negative 2y squared plus 100 over square root of 100 minus y squared equals 0. Now using cross multiplication, if we use cross multiplication, if we multiply this one by 0, it will be just 0. But if we multiply this term or this polynomial by 1, it will be itself. So we just have this one. We just have the numerator. We are going to continue here. So negative 2y squared plus 100 equals 0. We can move this one to the side. It will be 100 equals 2y squared. Divide both sides by 2. Cancel this and this. So y squared equals 50. Square both sides. Cancel this with this. So y equals, so we are not going to use the negative one. Why? Because y is the height. Height cannot be negative. So just take the positive one. So this will be 25 times 2. Square root of 25 is 5. So 5 radical 2. And this is the height. Now we need to find the base as well in order to get the area, because we need to find the maximum area, but we don't have the base. How to get the base? We can put y in equation 2, secondary equation. So put y in equation 2. In equation 2 is 100 minus y squared, and y is 5 radical 2 So it will be 100 minus 5 radical 2 but squared because it's y squared. And now this will be 100, 5 squared, 25. Radical 2 squared, 2. 25 times 2, 50. 100 minus 50 is 50. 50 is 5 radical 2. So this is the base. Now we put height and base both in primary equation. We can get the maximum area of a right triangle. So area is half of base and height. Half of base is x, so it's 5 radical 2, and height is y. Y is 5 radical 2. Now we can say 5 times 5, 25. Radical 2 times radical 2 is 2. So it will be 1 over 2 times 25 times 2. Why? Because 5 times 5 is 25. Radical 2 times radical 2 is 2. 25 times 2 is 50. 50 times half is 25. So the maximum area of this right triangle whose hypotenuse measures 10 centimeters is 25. And this is the answer. Thank you so much.